So we're back. We're back. GED Math Monday. So good evening. Good evening. I'm gonna continue to have GED Math Monday. Someone's email said, "Oh, Mr. Tinsley, you're not having it anymore." It's just that my dad was sick now, and we're gonna move that his chemotherapy to Friday. I'll be able to make sure I log in on Mondays, every Monday. So we're gonna continue back. And I got another email. I will update everybody who passed. I got about 11, 12 people who passed. I will update the congratulations for people who did pass. So I'm sorry about that, but I'm back on my job. My website is back up. My website was down, but my dad being sick, I just kind of, you know, lost track of everything. But the website is back up and running. Um, the GED math course is up and running. So if you want that, just send me your email to passgedmath79@gmail.com, and I'll send you an invitation. Okay. All right. So let's go ahead and get started. Back where we started. We'll see what you need help in. So what do you need help in this evening?
Well, I was in Canvas actually like during the short break we had.
Okay.
So I just did like a couple of the algebraic quizzes.
Okay.
But I'm not gonna lie to you, Preston, I do still kind of find myself a little stuck with the word problems. Not so much
Okay.
as setting them up, but put them in the proper format. I know
Okay.
it
So
sounds bad.
let's look at uh you want to go to Canvas, you mean?
Yes, if it's okay.
Okay. No problem. Let me find it. I think this is it. I'm building two other courses in Canvas right now too. So let me make sure this is the one. Yeah,
Okay.
I'm building an IT course and I built a customer service course.
Oh, okay. Is this one of them where you got the square roots?
No, this is from the book.
Oh, okay.
So what happened was I was tutoring someone. They didn't know how to put cube roots and how to do cubes and cube roots in the calculator.
That would be interesting for me as well. I did take one of the quizzes on that. I didn't do too bad, but I did get lost on some of
Okay, so let's start with there first. Okay, so let me show you how to do
them.
cube and cube roots. Okay, on the calculator and without the calculator. So we know when we talk about exponents, you can raise something to a power. So when they talk about squaring something, that's to the second power. When you talk about cubing, that's to the third power. So for example, 3 to the third is 3 times 3 times 3 equal
Right.
27. 5 to the third, well, 5 is the base, 3 is the exponent. So 5 times 5 times 5 equal 125. So
Mhm.
how you would do that on the calculator is 5 caret 3. Okay, so on the calculator, you would go 5, the caret is right there above x squared, and then
Mhm.
3. And that's how you raise to a power. Okay,
Okay. Gotcha.
so you will have squares, square roots, cube, and cube roots on your exam. I can almost guarantee.
Okay.
Okay, now when we talk about cube root, which is the opposite of cubing. So for example, if we know 5 to the third is 125, the cube root of 125 is 5. So in the book, in the ebook, and in class, I want you to know your squares, square roots, and cube roots by heart. But if you don't, you should know how to do them on the computer. I mean, on the on the calculator. So how would you do cube root? So first you do the nth root. So right now we're doing cube. So you put your 3 first. And then right above the caret in green, you'll see X and you'll see the root symbol. So
Yeah.
because it's in green, we're going to hit second. We're going to hit the caret. And then you'll see cube root of 125. We get out of that root, and its answer is 5. So that's how you would do. So let me clear the screen first so you can actually see it. So then when you take your calculator, you can put exactly what you see on the screen right there. And that's how you do cube and cube root. Well, the same thing for square and square root. Again, square is right there. So 4 squared is 16, 5 squared, 25. So now, if we want the inverse operation, it's right above x squared. It's in green, so we need second. So second, square root of 25, get out of your root, 5. Square root of 16, is 4. Okay, so now they're probably not they're not going to be that easy on the exam though. That's the problem, and this is what people get confused because a lot of people say, Mr. Tennessee, I know my cube and my cube roots. Well, that's what happened in my tutoring session. She said, I know all my squares, I know all my square roots, I know my cube and know my cube roots. But she saw a problem like this. Let me show you. Let me show you. Make it nice and big. Again, this is a practice problem in the eBook. It says the
Mhm.
square root of some number squared is 12. So this is a common question on the GED first 5. What you should know is that square and square root are inverse operations. So what happens is this square and this square root cancel each other out.
Mhm.
So that answer is just 12. So the square root of 12 squared is equal to 12. That's another way for them to see if you understand that square and square root cancel each other out. But most people get it wrong because they're not used to seeing it in that manner.
Exactly.
But it's one of the easiest problems on your exam. Okay,
Okay.
and they love putting it on there. It's probably on out of 3 exams. It's probably gonna be on 2 of them. All right, so let's go back to what you originally wanted. You said in Canvas, right?
Yes, I was in Canvas, and it was the algebraic word problems.
Let's see.
Um, where just like the guy was getting a commission, like if he was headed for like 40,000 or something like that, and then it ended with how would he be able to get 100,000? I was like, uh-oh. And
Now,
I got myself lost.
you gotta so is it linear equations or so? Tell me what section it was in.
Okay, when you go to quizzes, because I went to quizzes,
Okay,
mhm, it is the okay, go up a little bit. It's going toward the algebraic word problems, linear equation word problems.
okay. So that's the key. That's the key. Linear equation word problems because you can have a
Yep.
word algebraic word problem. But let's see, why is it going so slow here? I don't know. Hey, Miss Davis, how are you?
I'm good.
Glad you could join us. So you
Yeah.
said linear equation word problems, right?
Yes.
The first one.
Yes, that would be perfect. Yes.
Let's preview. Let's see which one we talk about. That one right there.
Exactly. Yes. Ooh, I
Okay,
think we did this one, but
that's okay. So what you're trying to do is this is what you need to understand about linear equations. It's very important that you understand. The slope-intercept form of a linear equation is y equal mx plus b. Okay. You have 2 terms on the right side, right? You have mx, where m is the slope multiplied by some number x, right? Plus
yes.
b. Okay. So when you look at this, you have the 2 terms. So you have 1 and you have 2. This first one is going to change. So it's variable. It's going to change. The plus b or minus b, whatever whatever it is
Constant.
constant. That's not going to change. So when you have a word problem like this, you're looking at something that could possibly change. And then the thing that's not going to change. So when you look at this as a machine salesperson earns a base salary of 40,000 plus commission of $300 for every machine he sells. So no matter how many machines he sells, what is this person going to make?
40,000.
40,000. Is that going to change or is that constant?
That's constant.
So that should be plus a commission of $300 for every machine he sells. So if I sell 1 machine, it's 300 times 1. If I sell 2 machines, it's 300 times 2. So that number is going to change depending upon how many sewing machines or whatever. What are they selling? Some type of machines, right?
Yeah.
That is variable. That's going to change. So this is your slope. So if that's my M and that's my B, if I rewrite my linear equation, I got y equal 300x plus 40,000. They're telling you what X stands for. X is the number of machines. So this is not a hard problem. What happens is when people see word problems, they, oh my God, I don't know how to do it. No, again, what you should be hearing, you should be hearing my voice in your ear. Identify your givens. What do I know? That's what you should be saying. Well, since they're talking about a linear equation, I know I'm starting y equal max plus b. I know m stands for my slope. I know b stands for my y-intercept. I know my b is constant. So what number in this is not going to change no matter how many machines I'm going to sell. Okay, so 40,000, my base salary, that's not going to change. That's my constant, or that's my B, or my y-intercept. 300 for times every machine I sell. So that can change. So that's my slope. 300 is my slope. So now, so what is the linear equation? Y equal 300x plus 40,000. Now listen to what they ask you. What would the salesperson income if he sold 150 machines? What they're basically telling you in words is that X equal 150 because X is the number of machines. They're telling you how many machines? 150. So now all you're going to do is substitute that into this equation to solve for Y because Y is how much the person makes. So Y equal 300 times 150 plus 40,000. So let's do for times by 100. That's 30,000. So that's 15 is 45. 65. Okay, so we got 45,000 plus 40,000. I did mental math, but let's do it on the calculator. So I got 85,000 in my head, but let's use the calculator. So let me save this.
85. Yep, you're right.
Let me clear it. And let's grab the calculator and put it on our screen. So y equals 300x. So 300, the number of machines was 150 plus 40,000. So you don't even have to go into the difficulty of having to do this by hand. You can use the calculator because we know how to substitute or evaluate an algebraic expression. We just plug that in and we get 85,000. Okay, but the important thing for you to know is that identify what's changing and what's not changing. What's not changing is your constant. What's variable or changing is going to be your slope. How many machines would the salesperson need to sell to earn 100,000? Again, these one of these word problems. Oh my God, Mr. Tinsley, I don't know what to do. Yes, you do. You have the equation that tells you how much you're going to make. That equation is y equal 300x plus 40,000. That's how much you're going to make. That's your equation. So you have to have a conceptual understanding. So if I sell one machine, it's 300 times one, which is 300 plus 40,000. So I'm going to make 40,300. If I sell 150 machines, I'm going to make, as we saw before, 150,000. What they want to know is, just like we do in real life, well, how many machines would I have to sell to make 100,000? So we got to identify, okay, so y equals mx plus b. We know what the equation is. Y equals 300x plus 40,000. So we know X stands for the number of machines. So therefore, Y is equal to our salary, our total salary. So since they said our salary is $100,000 income, we're going to substitute that in for Y. So we're going to have 100,000 equal 300X plus 40,000. Now we have one unknown. Now we can solve for X. X is the number of machines. So and that's the answer. How many machines we would have to sell to earn 100,000. So in order to solve this two-step algebraic equation, what would I do first?
We want to subtract 40,000.
Subtract 40,000. I'm gonna run out of room fairly quickly. Whatever we do to one side, we do on the other.
Mm-hmm.
100,000 minus 40,000 is 60,000 equal, oops, I forgot a zero, equal 300x. How can I solve for x?
Will we be dividing
Dividing by what?
300x? Okay.
300x.
Wait,
How can we get x by itself?
x by itself. Dividing 300.
By 300. We
Six.
divided by
Okay.
300x, they would cancel. They would
They
cancel each
would
other out.
cancel.
Remember the goal. We're trying to get x by itself because so you can't divide by x because they would cancel each other out. So the two 300s cancel. We get x equal to 60,000 divided by 300. Since we're dividing by, we know the powers of 10. So since we have two zeros here, we're going to cross those out. We have two zeros at the end here. We can cross those out. This is the same as 600 divided by 3 is equal to x. So x equal 200. So we would have to sell 200 machines to make 100,000. Now that makes sense. Why? Because we knew on B we sold 150 machines and we made what was it 80? What was it 80,000? 85,000?
85. Yes.
So right away we knew our answer had to be bigger than 150. So if they gave us multiple choice, we kind of would get the answer. So this is why I put these types of problems here because I want you to work through them so you can understand each step. So now if you understand one, what you should be going now is let me identify or let me solve another one. Let me see if I know how to do it. So let's go to another one. And it's the same process or similar process rather. Every question is not going to be the same. Okay. Now this is a little different, but let's try it. At a school play, children's tickets cost $3 each. And adult tickets cost $7 each. The total amount of money earned from ticket sales equal $210. Write a linear model that relates the number of children's tickets sold to the number of adult tickets sold. Let X equal the number of children's tickets sold and let Y equal the number of adult tickets sold. Mr. Tinsley, I don't know how to do this problem. Oh my God, what are they talking about? It's not hard at all. If I'm selling children's tickets, so children's tickets plus adult tickets equal 210. Okay, the amount of money I made selling children's tickets plus the amount I made selling adult tickets is equal to 210. Understand that?
Mm-hmm.
Okay. How much does these children's tickets cost?
Children's tickets.
How much does
Is it 7 children's tickets cost $3 each?
Okay, again, identifier given. Adult costs three and adult costs seven. So let me ask you a question. Let me just ask you a question. If I had 3 children's tickets, how much would I have to spend?
$9.
How did you get that?
I added 3 plus 3 and then 6 plus 3.
Oh, that's let me tell you something. If you do it that way, you're gonna be sitting here. So if I had 100 tickets, if I had 100 tickets, 100 children's tickets, how much would I make? How much would they cost? If I had to buy 100 children's tickets,
70.
where'd you get 70?
No, that's not right. I'm sorry. So 100 children's tickets at $3. Are we multiplying that?
You tell me.
At $3. I think we would multiply 100 times 3.
Exactly. So that's the point I wanted to tell you. So first you talking about 3 plus 3 is 6 plus 3 is 9. Listen, for 100 tickets, you be sitting there all day. 3 plus 3 plus 3 plus 3 plus 3. understand if you're adding the same number multiple times, that's what multiplication is. So
Okay.
3 times the number of children's tickets. Well, the number of children's tickets is X. So $3 times the number of tickets I have. So that's 3X. Understand that?
Yes.
Plus, how much do adult tickets cost?
$7.
What's the variable for the number of adult tickets sold? What's the variable for the number of adult tickets sold?
Y.
Y. So 3X plus 7Y equal 210. That's my linear equation. That's it. That's it. What happens is we get so inundated about word problems. We get so scared. But you have to go common sense. Common sense tells me the money I made from children's tickets plus the money I made from selling adult tickets is going to give me $210 because they told us children's tickets cost 3, adults cost 7, but we made a total of $210. So children's tickets, the amount of money we made from selling the children's tickets plus the amount of money we sold selling adult tickets equal 210. Well, how can I find out how much I made from selling children's tickets? You gave it to me 3 times the number of tickets. So we don't know how many tickets, but they gave us a given. X equal the number of children tickets sold. So that's 3X. Do the same thing for adult tickets, but adult tickets cost $7. So 7Y equal to 10. That's my linear equation. Again, these take practice, but the more and more you do them, once you see 1 or 2 done, you go back in and you keep doing them till you have a full conceptual understanding of the problem. Because you're going to have 2 or 3 of these on your exam. Guaranteed. How many children's tickets were sold if 24 adult tickets were sold? So that means we're going to take this 24. That means what variable is 24?
That's gonna be 24Y. No, 24X.
Okay, look what it says 24 adult tickets. What variable is for the adult tickets?
Y.
24Y.
No, no. Listen to what I'm asking. I'm not telling you to do any calculation. See, that's when you're going a step ahead. They're telling me you got 24 adult tickets. What variable stands for the number of adult tickets sold? What variable stands for the number of adult tickets sold? You don't have to think too hard. It's right in front of you.
Y.
Why? It's not hard. So this is why. They're telling us 24 adult tickets. So the number of adult tickets is Y. They're giving us Y here. So we're going to take this Y and plug it in right there. So we got 3X plus 7 times 24 equal to 10. Understand that?
Yes.
We bring down the 3X. 7 times 24 is 140 plus 28 is 168 equal 210. This is now a 2-step algebraic equation. 3x plus 168 equal 210. What can I do first to solve for x?
You put a, you want to cancel one. So you put a negative 168
Okay, so we subtract 168 from both sides.
on both sides, yeah.
We get 3x. The 168's cancel. Bring down our equal. 210 minus 168 is 32 and 10, so that's 42. We still haven't solved for x. What do we need to do to solve for x now?
Divide
Divide by what?
3.
Divide both sides by 3. The 3's cancel. I'm going to have to move over here. X is equal to 14. So remember, X stands for the number of children's tickets sold. So how many children's tickets were sold? 14. Another way you could do it is if you have multiple choice, just plug each one of them in until you got $210. What do you mean by that, Mr. Tinsley? Let's see. So let me clear it. And say I had multiple choice, and A was 10, B was 12, C was 14, and D was 15. So how many children's tickets were sold if 24 adult tickets were sold? So I would do, we know the original equation was 3x plus 7y equal 210. We identify 24 adult tickets, so that's y. So we get 3x plus, again, 7 times 24 is 168 equal 210. So we can just plug each one of these in it and see if we get 210. So let me clear it. Let me show you exactly what I'm talking about. So you don't even have to worry about all the algebra in this problem. Let me clear it. I didn't clear it. Okay. So the first multiple choice is 10. So 3 times 10 plus 168. Did I get 210?
No.
No. So go to the next multiple choice. 3 times 12 plus 168. Did I get 210?
No.
Go to the next multiple choice. 3 times 14 plus 168. Did I get 210?
Yeah.
Yeah.
So now I just figured out how many children's tickets I sold. 14. Without solving for X. Okay, so but you have to understand what they're giving you. So this is why, like, say you had problems with this test, with this quiz. You might have to take it 4 to 5 times until you fully understand, okay, what is meant? What are they giving me? What formula do I need to use? How do I solve that? Because if you notice, all of these, right, are what? Multiple steps, multiple concepts, right? So it's not just one thing that you need to know. So, but that's how you would do that problem. All right. So again, B would be, C would be, number of children's tickets sold would be 14. Okay. And that's without solving it algebraically. That's using multiple choice. Again, you have to be prepared. You have to be prepared to answer every question.
Couldn't pass it. Listen, I ain't paying attention.
Hey, Siani, how you doing?
Hold on, he said, "Hey, Siani." Hey,
Yeah, I hear your noise in the background.
oh my bad.
That's okay. So let's look at this one. We're gonna try one more before we move on. Again, this is linear equation word problems. Okay. Let's see if we can identify how to do this problem. And I want y'all to walk me through. What do you think you would do? Lynn is tracking the progress of her plant's growth. Today, the plant is 5 centimeters high. The plant grows 1.5 centimeters per day. Write a linear equation in slope-intercept form that represents the height of the plant after D days. What? What are they talking about? You cannot get yourself, don't even say that to yourself. What you should be saying when you read something and you're confused is identify your givens. What do I know? What do you know? Walk me through how to solve this problem.
Let's see. Y equals MX.
Say it out loud. I can't hear you.
I'm sorry.
Y equal mx plus b.
So first, it tells you to write a linear equation in slope-intercept form. So y equal mx plus b. But hold on, Mr. Tinsley. Ain't no b's and no y's and ain't no x's and no y's. They talk about d and some other letters, right? So first of all, identify your m and your b first. You can always change the variables. You can always change the variables. So in this case, how would I identify the slope in the y-intercept? How would I identify the slope in the y-intercept? So remember what I told you. You're going to identify something that's not going to change, is going to be a constant, and something that's variable, something that is going to change. And that's how you identify the slope and the y-intercept.
Would the slope be 5 centimeters?
Why would the slope be 5?
Well, today the plant is 5 centimeters. The plant grows 1.5 centimeters per day.
So again, this is where you have to use your common sense. If it's growing 1.5 centimeters per day, that means day 1, how tall is it?
1.5 centimeters.
1.5. On day 2, how tall is it going to be?
1.5.
No.
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 No, because it goes 5
grows
centimeters high.
1.5 per day. So on the second day, how tall is the plant going to be? 3. So listen to what just happened. On first day is 1.5. On the second day is 3. On the fourth day is 4.5. That means this, included with this 1.5 centimeters per day, that is my M, because that's changing. When I start, how tall is this plant?
1.5.
When I start, how tall is this plant?
1.5.
When I start, how tall is this plant?
5 centimeters high.
5 centimeters high.
Okay.
Today, the plant is 5 centimeters high. Tomorrow, how tall is my plant going to be?
1.5.
But where did it start?
It started at 5 centimeters.
So the additional 1.5, how tall is it going to be?
6.5.
6.5. So what that tells me is that this is my B, because that's not going to change from day 1. That's going to be 5. Then after that first day, then it's going to change. So this is my B, 5 centimeters. This is my M, 1.5. What will my equation be? What will my linear equation be to figure out the height of this plant?
Height equals 5x.
Okay. What did we identify as our slope? So y equal. You said 5x.
5x
5x
plus 1.5.
Okay. Again, we're not paying attention to what we're given. What did we say our slope was?
3.
What letter stands for slope?
M.
M. So what did we say our slope was? What did we say our slope was?
5x.
Okay. I guess we're not looking at our screen carefully. Okay, let's start over. Y equal mx plus b. What does M stand for?
The slope.
What does my B stand for?
Constant.
But what in the linear equation, what does my B stand for? So maybe that's where we need to start. B is my y-intercept. So first you have to understand a linear equation. Before you can really go into the word problem, you must understand a linear equation. So let me rewind and go backwards before we come back to this word problem. So let me save this. Let me clear it, and let me go to a blank sheet. Okay. Because we need to understand, see, and this is why step by step, we have to understand each step of the way. You can't remember math. You have to know it. So we said y equal mx plus b. We said m was our slope. We said b is our y-intercept. Okay. So if I have an equation, y equal 2x plus 3, what's my slope?
2x.
2,
2, not 2x.
2,
M is my slope. M is in front of the x. My slope is 2. What's my y-intercept?
3,
3. If I have y equal 1/2 x minus 5, what's my slope?
1/2.
1/2. What's my
1,
y-intercept?
-5.
-5. Okay. What does that mean? What does that mean? So when we talk about a linear equation, right? It's mean you're going to have a line on a graph, linear, L-I-N-E-A-R. You're going to have a line on a graph. Okay, so if I draw this, let me explain something to you, right? So we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My y-intercept is where the line crosses the y-axis. Where my line crosses the y-axis. That's what my y-intercept is. My y-intercept is +3. So that means when x is 0, y is 3. So now I'm going to go, remember my slope is 2, which is 2 over 1. That means my rise is 2. I'm going to go up 2, 1, 2 over 1. Okay, that's how you draw the graph for this linear equation. But you have to understand that this linear equation means something. For example, say if I was selling pretzels down at the stadium, right? And when I started with $3. Somebody just gave me $3. I don't know, plus $3. But every pretzel I was selling, I made $2, right? So that's my Y, that's my money. So if I sold one pretzel, 2 times 1 is 2 plus 3 is 5, I would have $5 in my pocket. If I sold 2 pretzels, 2 times 2 is 4 plus 3 is 7. So these are all points on this line. 1, 5, 2, 7. That's what a linear equation means. It means you're going to have a constant rate of change. That's what slope is, a constant rate of change. The y-intercept is what you made when x was 0. So when I sold no pretzels, how much money did I have? I had $3. Now, normally, if we was talking about pretzel sales, this wouldn't be a +3. It'd probably be a -10 or something because it cost me $10 to buy the pretzels. And then I made $2 for each pretzel. So normally in real life, that wouldn't be a +3. It'd probably be like a -10 or some minus number. But that's what a linear equation does in real life. Okay. Let me give you another real life example. Okay. My sister-in-law sells platters. Sells platters for $20 each. She spent $150 for her supplies to make the food. What would be the linear equation? Okay. So, what, Mr. Tenzi? Yes, this is a real life problem. A real world problem. This is an actual way you would calculate how much revenue you would make selling food platters. This is why most people don't make a whole lot of money when they sell food out of their home because they don't know what price to make each platter. They just pick a number. And hopefully that number is enough for you to make a profit. But that linear equation would be, first of all, $20 for each platter. That's variable. That's going to change. My minus 150 or 150 is my y-intercept. But again, that money went out. So that's minus 150. So my linear equation here will be what? Does anybody know? would be my linear equation to figure out how much I would make selling platters?
Would it be y equals 20x plus 150?
Is it plus 150? Or did you have to spend your money to get the supplies?
You had to spend the money to get the supplies.
So it's minus 150.
Minus 150. Okay.
So what you would have, this is the things that you would have to do to solve this. In your mind, you would say, how many platters would I have to make to break even? Okay, so again, how do we do that? Okay, 20x minus 150, right? So how much would I make? Let's just take an example. Let's do a table. Okay, if I sold 0 platters, I will be 150 in the hole because that's the money I spent. That makes sense. So that means my y-intercept is negative 150. If I sold 10 platters, 20 times 10 is what? Everybody should know 20 times 10 is at the top of your head. That should be mental math. What's 20 times 10?
200.
200. 200 minus 150 is $50. So you did all this work for $50? No, we're not selling 10 platters. Again, this is the math that goes in. If I sold 20 platters, 20 times 20 is 400, minus 150 is 250. If I sold 50 platters, 20 times 50 is 1,000, minus 150 is 850. So again, you would, if you wanted to know how much you would break even with, you would say 0 equal 20x minus 150. Again, solve for x, add 150 to both sides. I'm going to write over here, 150 equal 20x. Now it's not going to go evenly. Divide both sides by 20. You're going to get 7.5 equal x, right? So to break even, you can't sell 7.5 platters. So to break even, you would round off and say, I need to sell 8 platters to break even. That's my break even point. This is real world linear equations. So now you know you need to sell 8 platters to break even. Once you sell those 8 platters, you are now in the profit area. You're now making money. This table shows you what happens, how many platters, if you sold 10, if you sold 20, if you sold 50. But you don't know how many you're going to sell, right? Depends how much that 150 supplies gave you, right? But at least you have a way to figure out how much you're going to make. Okay, so this is why you have to read each problem carefully. Is it plus 150? Is it minus 150? What's changing? That's my slope. That's why it's 20x. You were almost right. You just said 20x plus 150. But you got to realize that 150 is an expense that's being taken away. So that's minus 150. Okay, so let's look back at that example. Because a lot of people say, oh, are we ever going to use linear equations? Yes, you probably going to use linear equations. Now, you might not use quadratic equations, but I just showed you a real life example where you use linear equations. Now, so let's go back. Let's reiterate. So identify what's given. So this is how you should be reading this question. First of all, what did I tell you to do? Read the question first. Write a linear equation in slope-intercept form. So I already know y equal mx plus b. That represents the height of the plant after d days. Now, that means we're not going to be using y and x. We're going to be using h and d, right? Because h for height, d for days, but that's okay. We identify what's given. We started, the plant is 5 centimeters high. That's my b. It grows 1.5 centimeters per day. The word per gives you the clue, means it's changing every single day. That's changing. That's variable. That's what variable means, to change. That's my m. So y equal 1.5x plus 5. We're not using y and x. We're using H and D. So my height after D days. So H equal 1.5 times the number of days plus 5. That would be my linear equation. So the second part says, what will the height of the plant be after 20 days? So they're telling you D equal 20. Plug that in. So H equal 1.5 times 20 plus 5. So 20 times 1 is 20. A half of 20 is 10. So that's 30 plus 5. H equal 35. So after 20 days, the height of this plant will be 35 centimeters. That's a word problem, a linear equation word problem. You will have 2 to 3 of these on your exam. Can almost guarantee you that you're going to have these. But first, you must understand several things. First of all, what's a linear equation? What's M? What's B? What does that mean? My B is my constant. My M is my term that's going to drive that first term that's going to change. My M is my slope, but that X is going to change that term. That's going to be variable because of X, because X is unknown. It can be anything. Okay? So those are the things you have to take your time when you're doing these problems. The slope-intercept form, since standard form, identify what form. Identify your variable. Identify what's given, and you work at them. It doesn't matter if you get it wrong, but you have to work at it until you fully understand it. Because in your mind, when you get to the GED, you can't be scared of word problems. Because you should have went through my course so much with all these word problems, you shouldn't even be scared of a word problem. You can be like, oh, I got this. I understand it. But it doesn't happen overnight. It takes practice. Let's try one more. 650. Let's try one more.
Wow, that quick.
Yeah, time flies, don't it?
Time is flying.
So write a linear model. So that's a linear equation. Y equal mx plus b. Where Miss Thompson's weight after m months. Okay. So we don't know which one is going to be yx, but let's figure it out. Mr. Thompson is on a diet. What is our givens?
He weighs 260 pounds.
Is that my M or my B?
That's the B.
That should be. But that's what we're starting with. Okay. What else is a given?
He loses 4 pounds per month.
He loses 4 pounds a month. What is that? So if we know that's our B, what is this?
That the change. That's the
If the weight, if his current weight was B, what's losing 4 pounds per month?
B is constant. Is the 4 pounds the change? That's the M.
That's the M, the slope. Because it's losing, is it positive or negative?
Negative.
So my M is negative 4. So Y equal negative 4x plus 260. Understand that?
Mm-hmm.
Now, it says 4 pounds per month. We used X. Remember, it doesn't matter what variable you use. So we're just going to change our X to the variable that they gave us, which is M. That's what causes the confusion in this problem. M stands for slope as a linear equation. M, the variable, stands for how many months. So Y equal minus 4M plus 260. That would be the linear equation. For how many months will Mr. Thompson reach his goal of 220? So is 220, is that my Y or my M? So I got two variables in this equation, Y and M. Is this 220 pounds Should that go here as y or should go here as m?
That's changed. So would it go in the place where the -4 is on the M?
Well, what does m
No,
stand for? You already told us what the m stand for.
no, that's for months. Okay.
So 220 pounds cannot be m. So again, identify your givens. M is for the number of months. They told us 220 pounds. It can't be m. So it can't be m. So that means that's y. So we plug that in. So we get 220 equal minus 4m plus 260. How can we solve for m? What do we need to do first? How can we solve for m? What do we need to do first?
We subtract 260.
Subtract 260 from both sides. You get minus 40 equal minus 4m. What's our next step?
Mhm. Do we divide -4?
Divide by -4 on both sides. The -4s on the right side cancel. We get m equal. Two negatives make a what?
Positive.
Positive. Was 40 divided by 4?
10.
10. So in order for him to go from 260 to 220 pounds, how long is it going to take him?
10 months.
10 months. There wasn't nothing. It wasn't nothing to
Mhm.
do. M equal 10. What does M stand for? The number of months. So it'll take him 10 months to get down to 220 pounds. Again, another real life scenario. Because when you're trying to lose weight, you have a goal in mind. I'm going to try to lose 4 pounds a month. I'm going to try to lose 2 pounds a week. I'm going to try. That's a real life scenario. So in this case, if he's going to try to lose 4 pounds a month to go get down 40 pounds, it would take him 10 months. And this is how you attack a linear equation. Word problem. Again, watch my video. I got another video on YouTube, on my YouTube channel. Put in linear equation word problems. It'll come up with a video, and I'll go through the same thing. We almost probably the same problems that we're doing here, or very similar. Again, identifying your slope, identifying your y-intercept will help you go a long way. What's changing, what's not changing, and you have to understand it. Now, the advantage you have is that you're going to have multiple choice. So, for example, A is 8, B is 10, C is 12, D is 13. Okay, so if I'm so how would I do it? So y equal minus 4m plus 260, right? I got to get down to 220. So minus 4 times 8 plus 260. So minus 32 plus 260, I get 228. That's not it because we're trying to get down to 220. That's not it. Okay. So second multiple choice. 10 months minus 4 times 10 because M stands for the number of months plus 260 minus 40 plus 260 is 220. Ding, 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 ding. Answer done. That's without doing any algebra. But you have to know how to set that linear equation up. Because if you know how to do that, then you can use the multiple choice to get your answer. Okay, so practice with now. I believe I have linear equation word problems 1, 2, and 3. So I gave you enough problems for you to really get practice. Okay?
Got it.
So believe it or not, it's already 7 o'clock. Time fly. Again, don't worry. I'm gonna build it back up. Now that my father has changed his doctor's appointment, I should be available every Monday at 6 again. I do apologize for that. So anybody who looks at this video, I do apologize for not being consistent for the last 2 months. But Now we changed his chemotherapy days to they're going to be changing them to Friday. I should be available every Monday. Okay.
Okay. Thank you,
Okay.
Professor
For this
Tinsley.
year, 2024, let's knock this math exam out
Yes.
Yes, my God.
and have a wonderful, wonderful
Yes.
night.
Okay.
Thank you,
Thank
Professor
you.
Tinsley.
You're welcome.
Have a
Thank
nice
you.
evening, sir.
Bye bye.
Have a nice evening.
Thank you. Are we on
Yeah.
tomorrow?
Tomorrow I'm working tomorrow.
Okay. All right.
Okay.
So have a good
But
evening.
I'll see you next week, Monday. I'll be
Okay.
on.
Okay.
Yes.
I'll see you next Monday.
Okay.
Definitely.
All right.
Thank you. Bye-bye.
Okay.